So we had left off here with the 1.175, and I just wanted to make a couple comments about that before we headed away. The reason this is a little bit easier now in Chapter 6 than it was in Chapter 3, because if you remember, we did this exact same table stuff in 3.3. Go back and look at the videos. They're there. But this is simpler now, and the reason it's simpler is this guy right here. The fact that the sum is equaling to 1. See, the mean is normally you add up this column and you divide by the total of the weights. But the weights are always going to add up to 1 because it's always going to be a probability distribution in Chapter 6 because we're working with probability distributions, right? And the sum must be 1. That's one of the rules of probability. Same thing's happening here with the variance. Normally what you do is you take this column and you divide by the total of the sum, the frequency column, but the frequency here is always going to be 1. So it's simpler in this particular chapter than it is in Chapter 3. So just something to keep in mind. I bolded this and highlighted it just so you could see it a little clearer. Now, actually, I haven't moved ahead. There was a technical difficulty, so one of my videos got lost. So let me just tell you what I did here. The next question asks the mean of the random variable and the standard deviation of the random variable for the 25 simulations. So let me click on the data. This one's the 25 games. So what I did, and again, it's in a lost video now. Someday you'll find it in archives. So here I typed in the 25 data points right here. You can see them. There they are. So I typed them all in, and then I found the average, right? Here's the formula, equals average of that data. And then I found the standard deviation, equals standard deviation of that data. There we go. And so I typed those numbers in right here. Oops, maybe you can't see that very clearly. There we go. So I typed in the average right there, 1.8, and then I typed in the standard deviation. Now this is where my computer froze on me, but it wanted me to do it again for 50 games. So what I did was I went in here and typed all 50. You can tell there's 50 because I started at the first one, and look at that, 50th row is the last one. I hope I typed them all correctly. All right, so I want the average of, and I'm not going to scroll to do this, it's B1 to B50, right? Because I started in cell 1 and I typed until I got to 50. So this is the mean. And then the standard deviation will be equal to STDEV, again, B1 colon B50. That way. All right, according to this, it's going to be 1 point, oh, they want 3 decimal places. Oh, there aren't 3 decimal places. Okay, so 1.660 should be what it is. Let's see if I typed them right. Oop. No, maybe it doesn't like the 0. All right, that must mean I typed something wrong. Let me go back, double check the data. Worst things have happened. Oops, hey, come here. There we go. All right, let me pause for a second. I'm just going to go double check all my numbers. I had one number wrong. Can you believe it? Well, it happens, you know, and you just got to go back, double check. You know, if you're confident that what you're doing is right and you can't get the right answers, it could be, there it is, that you typed something wrong. So 1, 2 was a 1, or vice versa. All right, so this is 1.64, and the standard deviation automatically changed for me, so it's 1.225. Let me go in here. Enter. There we go. All right, what property is being illustrated? I probably will let you figure this out, other than to say that what we're doing here is we're trying to see what happens with real life. Let me scroll back up. All right, this is the classical mean, right? So this is what we hypothetically think would happen with this distribution. And then this is what happens when we had 25 games. See those numbers? And then this is with 50 games down here. It's a little bit closer to what we thought it would be than when it was 25, right? So when you're 50 games, you're 1.64. When you're 25, you're 1.8. And all in all, we're trying to get to 1.625. I'll let you think about that. I'm not going to answer that one for you. All right, I think that'll be enough to help you guys with this problem. See you later.